Hello dear students, welcome back to the class on mathematics. So in the last class we have studied about inverse hyperbolic function. We have seen the inverse hyperbolic function sin h inverse of x, and we have also seen the derivative of sin h inverse of x is 1 by root of 1 plus x square. Also from here it follows that the antiderivative, so integral dx by square root of 1 plus x square is sin h inverse of x plus c. Also we have shown that sin h inverse of x is equal to natural logarithm of x plus square root of 1 plus x square plus c. Now we will see one problem regarding the inverse hyperbolic sine function. So see example 2, find sin h inverse of phi numerically by using logarithms. So for here we have to simply use the formula. We know that sin h inverse of x is, we have sin h inverse of x. We have proved that it is equal to natural logarithm of x plus square root of 1 plus x square. So here instead of x we will put 5. So we will get natural logarithm of 5 plus square root of 5 square plus 1. So this is logarithm of 5 plus root of 26, and its value you can find the approximate value using the calculator. Now we will see the second problem, that is verify the formula dx integral dx by square root of 1 plus x square equal to logarithm x plus square root of 1 plus x square plus c. So we have to verify this formula. So it means that you have to differentiate the RHS, and we will show that it is equal to the integrand of the LHS. Okay. So it means that we have to show that d by dx of x plus square root of 1 plus x square plus c is not required because derivative of a constant is 0. This we have to show that this is equal to integrand of LHS, so square root of 1 plus x square. This we have to show. So we will start with here LHS. So that is derivative of ln of x plus square root of 1 plus x square. So we know that derivative of log x is 1 by x. So instead of x you have x plus square root of 1 plus x square. Now next we have to find the derivative of, usually what we do d by dx of x plus square root of 1 plus x square, because we have a composite function here. So d by dx of log x is 1 by x. Okay. So instead of x we have x plus square root of 1 plus x square. Now since it is a composite function, again we have to differentiate this term with respect to x. So it is equal to one by x plus square root of 1 plus x square into, here derivative of x is 1 plus derivative of 1 plus x square, so it is 1 by 2 square root of 1 plus x square into derivative of 1 plus x square, so it is 2x. Okay, so here what we did is square root of 1 plus x square is nothing but 1 plus x square whole raised to 1 by 2. Okay, so when you find its derivative, it will be 1 by 2 into 1 plus x square whole raised to minus half. So that's why I have written it in the denominator. So 1 by 2 square root of 1 plus x square into derivative of 1 plus x square. So it is 2x. So we got this. Now we can take here LCM. So 1 by x plus square root of 1 plus x square. Here 2 will get cancelled. If you take LCM, you will get square root of 1 plus x square plus x divided by square root of 1 plus x square. So these two terms will get cancelled and this is equal to 1 by square root of 1 plus x square. So this is the RHS. So since derivative of logarithm of x plus square root of 1 plus x square is 1 by root of 1 plus x square, it follows that we have verified this formula, because it follows that integral dx by square root of 1 plus x square is natural logarithm of x plus square root of 1 plus x square. So in the first semester you have already studied the concept of antiderivative. So like that it follows. So now we will do in the same way as we found the formula for the inverse hyperbolic sine function. Now in the same way we can do for the cosine function. Okay. So next we will define the hyperbolic inverse hyperbolic cosine function. So for sine and cosine, I will do all the steps here. So for all other hyperbolic function, you can do in the same way. So now we will see what is inverse hyperbolic cosine function. So usually it is denoted by cos h inverse of x. Okay. So we will derive a formula for that. So usually let y equal to f of x. If we write, then the inverse function we have x is equal to f inverse of y. In the same way, if you put y equal to cos hx, now this implies that x equal to cos h inverse of y. So this is the inverse hyperbolic cosine function, which is cos h inverse of y. We know that cos hx, we have studied the hyperbolic function cos hx. We know that it is an increasing function on 0 infinity. So its inverse, cos h inverse of x will also be an increasing function. And we will see how to find its derivative. So like we did for the inverse hyperbolic sine function, we know that d by dy of f inverse of y is given by 1 by f dash of x. So the same method we will use here. So f inverse of y. So f inverse of y is here cos h inverse of y. Okay, so we have d by dy of cos h inverse of y is equal to this 1 by f dash of x. So what is f of x? F of x is cos hx. So f dash of x means, so f of x is cos hx. So f dash of x means it is d by dx of cos hx. What is derivative of cos hx? It is sin hx. So we have sin hx. So here we will get 1 by sin hx. Now we know that cos x square x minus sin x square x is equal to 1. So from here we will get sin hx is equal to square root of cos h square x minus 1. So we will substitute this value here. So we will get d by dy of cos h inverse of y equal to 1 by root of cos h square x minus 1. Now what is cos hx? Cos hx is our y. We have taken y equal to cos hx. So you will get y square minus 1. And this y square minus 1 will be valid. Square root of y square minus 1 is valid only if y is greater than 1. Because if y is less than 1, inside the square root you will get negative terms. Okay. So this will be valid only if y is greater than 1. When y equal to 1, you will get here it denominator as 0. So that is also not possible. You should take the value y to be greater than 1. So we got the derivative of cos h inverse of y is 1 by square root of y square minus 1. So we have derived the formula. We can write it, we can replace y by x. So d by dx of cos h inverse of x is 1 by square root of x square minus 1, where x is greater than 1. So we have derived this formula. You have to remember this result. That is derivative of cos h inverse of x is 1 by square root of x square minus 1. Now as we did in the case of sine hyperbolic function, we will derive a formula for cos h inverse of x also. Okay. So we take let y equal to cos hx, and we know its formula is e raised to x plus e raised to minus x by 2. We multiply by 2 e raised to x. So we will get 2 e raised to x, y is equal to e raised to 2x plus 1. As we did in the case of sine function. Okay, e raised to x into e raised to x is e raised to 2x, e raised to x into e raised to minus x is 1. So I hope this is clear. Now this implies e raised to 2x minus 2 e raised to xy plus 1 equal to 0. Now this is an second order equation, second degree equation in e raised to x. Okay, so if we compare, we have a equal to 1, b equal to minus 2y and c equal to 1. So we know that the solution is minus b plus or minus root of b square minus 4ac by 2a. So here the unknown is e raised to x. So we get e raised to x equal to minus b, so 2y plus or minus root of b square. So it is 4y square minus 4ac. So minus 4. AC is 1 divided by 2a. So 2. So square root of 4, inside square root we can take 4 outside. So 2 will get cancelled. So this implies y plus or minus root of y square minus 1. Now since e raised to x is positive, we have to take only the positive value. So e raised to x equal to y plus square root of y square minus 1. Now we know that exponential function and logarithmic functions are inverses of each other. So we can take logarithmic here. So this implies x equal to natural logarithm of y plus root of y square minus 1. Now in the beginning we have taken y equal to cos hx. So we got the value for x. So x is nothing but cos h inverse of y. So we substitute for x. This implies cos h inverse of y equal to ln y plus square root of y square minus 1. So we got an expression for the inverse hyperbolic function in terms of logarithmic. We can replace y by x and we have the formula cos h inverse of x is equal to natural logarithm x plus square root of x square minus 1. So we derived this formula. Also in the beginning we have shown that derivative of, we have already shown that d by dx of cos h inverse of x is equal to 1 by root of x square minus 1. Now from this it means that 1 by root of x square minus 1 is the antiderivative. Cos h inverse of x is the antiderivative of 1 by root of x square plus 1. So we can write this as integral dx by square root of x square minus 1 is equal to cos h inverse of x plus an arbitrary constant c will be here. And what is cos h inverse of x? Right now we have shown that it is equal to ln of x plus square root of x square minus 1 plus c. So we got these two results, that is for an integration as well as for derivative. So you have to remember these results. So d by dx of cos h inverse of x is 1 by root of x square minus 1. And from this we conclude that integral dx by square root of x square minus 1 is cos h inverse of x plus c. Since it is an indefinite integral, we have a constant c, which can also be written as logarithm of x plus square root of x square minus 1 plus c. Now we will see this problem. Find derivative of cos h inverse of square root of x square plus 1, where x is not equal to 0. So we know that derivative of cos h inverse of x is given by 1 by square root of x square minus 1. So here we have to find derivative of cos h inverse of square root of x square plus 1. So instead of x we have, in place of x here we have square root of x square plus 1. So in the formula also, instead of x we have to replace it by square root of x square plus 1. So I will take this to be y. Let y equal to cos h inverse of square root of x square plus 1. If we want, you can use the chain rule also. You can do substitution here, or you can directly differentiate. We can write dy by dx using this formula. If it is cos h inverse of x, its derivative is 1 by root of x square minus 1. So you will get 1 by root of x. Instead of x we have x plus square root of x square plus 1. So you will get x square plus 1 minus 1. So we have substituted it here. You have x square minus 1. So square root of x square plus 1 whole square will give you x square plus 1. Then minus 1. Now we have to find derivative of d by dx of, again this is a composite function. So square root of x square plus 1. So we see that here this is 1 by square root of x square, and d by dx of square root of x square plus 1 is 1 by 2 root of x square plus 1. Derivative of x square plus 1 is 2x. So this become Here you can see square root of x square. So 2 will get cancelled. This here you have mod x because x can be either positive or negative. The problem it is given x is not equal to 0. So it can be positive or negative. So actually mod x takes two value. Mod x is equal to x. If x is positive, it takes the value minus x if x is negative. So we got dy by dx. So dy by dx as it takes two value. If mod x equal to x, you will get x by x. So it will get cancelled. So it is 1 by square root of x square plus 1 if x is positive. If x is negative, mod x takes the value minus x. So in this case, we have x by minus x by square root of x square plus 1. Again, x will get cancelled, so there will be a minus sign. So minus 1 by root of x square plus 1. So this is the required derivative of the given function. So here you can do direct differentiation or we can use chain rule to get this. Now similarly we can do for remaining inverse hyperbolic functions also. Now it is easy to show that the derivative of tan h inverse of x is 1 by 1 minus x square, where minus 1 less than x less than 1. Now we will do another problem in which we will prove a logarithmic formula for tan h inverse of x. So the question is, prove that tan h inverse of x equal to half logarithmic 1 plus x by 1 minus x, where minus 1 less than x less than 1. So x lies between minus 1 and 1. So for this, let's put y equal to tan h inverse of x, which implies x equal to tan hy. Now tan hy is nothing but sin hy by cos hy. Now what is sin hy? We know we have studied in hyperbolic function that sin hy is e raised to y minus e raised to minus y by 2. And cos hy is e raised to y plus e raised to minus y by 2. So this 2 will get cancelled. We will get x equal to e raised to y minus e raised to minus y whole divided by e raised to y plus e raised to minus y. Now we do cross multiplication. So we will get x into e raised to y plus e raised to minus y equal to e raised to y minus e raised to minus y. Now we multiply with e raised to y on both sides. So we will get, so when we multiply here, we have x into e raised to y into e raised to y, which is x into e raised to 2y. So we'll get the first term x e raised to 2y. The second term is x into e raised to minus y into e raised to y, which is x into e raised to 0, which is e raised to 0 is 1. So we'll get x. So we got the second term as x. And in the RHS, when we multiply with e raised to y, we will get e raised to y into e raised to y, which is e raised to 2y, minus e raised to minus y into e raised to y, which is e raised to 0, and it is 1. So we got the equation x e raised to 2y plus x equal to e raised to 2y minus 1. Now we will take here e raised to 2y outside. So we will get x minus 1 into e raised to 2y plus x plus 1 equal to 0. From this we will write what is e raised to 2y. So we'll take x plus 1 to RHS. So we'll get minus of x plus 1 divided by x minus 1. Now x minus 1, I can take minus 1 outside. So I can write x minus 1 equal to minus 1 into 1 minus x. So minus minus will get cancelled. So we'll get e raised to 2y equal to 1 plus x by 1 minus x. Now we know that logarithmic function is an inverse of exponential function. So if you take logarithmic on both sides, we will get 2y equal to logarithm 1 plus x by 1 minus x, which implies y equal to 1 by 2 logarithm 1 plus x by 1 minus x. And y is nothing but tan h inverse of x. So we got that tan h inverse of x equal to half logarithm 1 plus x by 1 minus x. Now we will see one more problem. Show directly that the antiderivative of 1 minus x square for mod x less than 1 is half logarithm 1 plus x by 1 minus x plus c. By noticing that 1 by 1 minus x square is half into 1 by 1 minus x plus 1 by 1 plus x. So it means that we have to show that integral dx by 1 minus x square is equal to half logarithm 1 plus x by 1 minus x plus c. And also it is given that 1 by 1 minus x square is this. You can see that this is true. If you take the LCM here, you will get the same thing. So instead of 1 by 1 minus x square, we can write 1 by 1 half into 1 by 1 minus x plus 1 by 1 plus x. We know that integral of the sum is sum of the integral. So we can write this integral dx by 1 minus x square as half into integral dx by 1 minus x plus integral dx by 1 plus x. Now, integral dx by 1 minus x, integration of this is logarithm of modulus of 1 minus x, and here we have to divide by the derivative of minus x. Derivative of minus x is minus 1 plus logarithmic of 1 plus x, modulus of 1 plus x divided by derivative of x, so it is 1. So we get this is equal to 1 by n log modulus of 1 plus x minus log modulus of 1 minus x. Now log a minus log b is nothing but log a by b. So I can write this as half log modulus of 1 plus x by 1 minus x with mod x not equal to 1, because this is valid only if mod x not equal to 1. If x is equal to 1, you can see that the denominator becomes 0, so it is not valid. If x equal to minus 1, then numerator is not valid because log 0 is not defined. So mod x should not be 1. Also in the problem it is given that the domain is mod x less than 1. That is minus 1 less than x less than 1. Now we will show that this quantity 1 plus x by 1 minus x is positive, so that we need not write modulus here. You know, if a quantity is positive, because modulus of 2 is 2 itself, as 2 is a positive quantity. So if a quantity is positive, the modulus of that number is that number itself. So we'll show that 1 plus x by, our aim is to show that 1 plus x by 1 minus x is positive, which will imply that modulus of 1 plus x by 1 minus x is same as 1 plus x by 1 minus x. Okay. So for this we will show that 1 plus x is positive. So we know mod x is less than 1, which imply minus 1 less than x less than 1. That is, it means that x lies between minus 1 and 1. Now we add 1 on both sides. We add 1 on both sides. 1 minus 1 is 0, less than x plus 1 less than 2. So this implies from the first inequality we have x plus 1 is greater than 0. So we got the numerator is positive. Now we have to see the denominator. Denominator is 1 minus x. We know x lies between minus 1 and 1. So we want to know the variation of minus x. For this, multiply this inequality with minus 1. So we have 1. When you multiply with minus 1, the equality reverses. So we have 1 greater than minus x greater than minus 1. Now you add 1 on both sides. Add 1. So when you add 1, 1 plus 1 becomes 2 greater than 1 minus x greater than 1 minus 1, 0. So again from here we are getting 1 minus x is positive. So 1 minus x is positive. So numerator is positive and denominator is positive. So the ratio is also positive. So 1 minus x by 1 plus x is positive. So we can, since this is positive, we can avoid the modulus sign, and hence we have integral dx by 1 minus x square is half log 1 plus x by 1 minus x, where mod x is less than 1. Now we will see the graphs also. So we have the graph of the inverse hyperbolic function. We have this is the sin h inverse of x. At 0 takes the value 0. And we have the cos h inverse of x. This is also an increasing, cos h inverse of x is also an increasing function. And it is defined on 1 infinity. Sec h inverse of x, then cosec h inverse of x, tan h inverse of x, and cot h inverse of x. Now, since we know the derivative, we can define the derivative of inverse hyperbolic function. So, in the first class, we have proved this sin h inverse of x is logarithmic of x, logarithm x plus square root of x square plus 1. And also we have proved d by dx of sin h inverse of x is 1 by square root of x square plus 1. In this class, we have shown that cos h inverse of x is logarithmic x plus root of x square minus 1. So here we have plus, here we have minus. Also derivative, also you can see here we have plus, here you have minus, and the condition is that x should be greater than 1. Tan h inverse of x, we have proved this. There is half logarithmic 1 plus x by 1 minus x. This you can prove yourself. For the remaining hyperbolic function, you can inverse hyperbolic function, you can do it yourself. Derivative of tan h inverse of x is 1 by 1 minus x square, where mod x is less than 1. Cot h inverse of x is half log x plus 1 by x minus 1. This we can prove in the same way as we did for tan h inverse of x. And derivative of cot h inverse of x is 1 by 1 minus x square. Similarly for sec h inverse of x, cosec h inverse of x and their derivative. So these things you can do it very easily, and since we have the derivative, we can also write what will be the corresponding integral. So we know, so the integral of x square plus 1. So this integration, these formulas are more important. So integral dx by x square plus 1 is sin h inverse of x plus c. This we have seen in the first class. Then integral dx by x square, square root of x square minus 1 is cos h inverse of x. Similarly, integral dx by 1 minus x square is half log 1 plus x by 1 minus x plus c. So this formula you have to remember. Okay. Similarly, integral dx by x into square root of 1 minus x square is minus sec h inverse of x plus c. And integral dx by x into square root of 1 plus x square is minus cosec h inverse of x plus c. So these integral formulas you have to remember by heart, because when we do problems of integration, these formulas will be useful. Okay, so study all these formulas. In the next class, we will do some problems of integrations. Okay, thank you.